Laplace transform, part 3. So we're going to continue with the properties of the Laplace transform. So these are the table that you can refer to. So there are a lot of operations that we can consider with. So you have the table here. These are the operation, and then this is the st in time domain, and also xs in frequency domain. So you have addition, scalar multiplication, time differentiation, time integration, time and frequency shifting, frequency differentiation and integration, scaling, time convolution, frequency convolution, initial value, final value. So first is the linearity property. So when you have alpha xt plus beta yt in time domain, so what happened in the frequency domain is that you have to multiply it. So alpha ss plus beta ys. So it's linear. So time shifting property. So you have at t minus t naught, because this is shifting, the time is shifting. So what happened in frequency domain? You just have to multiply the transform ss with exponent minus st naught, provided that your t naught is more than 0. So a more accurate statement of the time shifting property is you have to include the step function. So you have at t minus t naught times ut minus t naught. So the step function also shifted. So in the frequency domain, you have xs exponent minus st naught. Time scaling. So here you have at because of the scaling. So the scaling here is a. So what happened in the frequency domain is that you will have 1 over a at s over a. For frequency scaling, meaning that the scaling occurs in the frequency domain, so you have at as. So this is the scale. So in time domain, it will be 1 over a at t over a. So notice the similarities in these two equations here. Frequency shifting property. So the domain that is shifted is the frequency. So that's why you have at s minus s naught over here. So the shifting occurs here. So what happened in the time domain is that you just have to multiply the time signal st with exponent s naught t. So observe the symmetry or duality between the frequency shift and also the time shift. So it's almost the same. So here you have the frequency shifting property, and this one is the time domain time shifting property. So there you have it. You have the linearity, and then the scaling, and also the time shift. Next, you have the frequency shift and time differentiation property. So time differentiation is when you differentiate your time domain. So you have d over dt as t. So what happened in the frequency domain is that you will you have to multiply s minus x 0 minus. Okay. So for second order time differentiation, so your st is differentiated in second order. So when you apply Laplace transform, you will have s squared xs minus s at 0 minus minus d over dt at 0 minus. Just refer to the table. So this is the general equation for the time differentiation. Next we have the integration. So for time integration, you integrate the xt domain. So you have x tau d tau. So what happened in the frequency domain is that you just have to divide it by s. Same goes for frequency integration property. So when you integrate your frequency domain, so you have integration of x z dz. So what happened in the time domain is that you just have to divide it by t. And this is frequency differentiation property. So when you differentiate the frequency domain, so you have here d over ds xs. So what happened in the time domain is that you just have to multiply that with minus t. So that's the summary of the time integration and also frequency differentiation. Let us refer to the first example. So determine the Laplace transform of ft is equal to t squared sine 2t ut. Okay, first you have to so sine 2t, if you refer to the table number 8b over here, so you have sine bt ut. So in frequency domain that would be b over s squared plus b squared. So by using that equation, you will have 2 over s squared plus 2 squared. And then after that, you are going to combine t squared sine 2t. So you have done the sine 2t part. Now the t squared. So that one will refer to the frequency differentiation here. So you have this equation, Laplace transform of t the power of n ft, that will give you minus 1 the power of n d the power of n fs over d s the power of n. So by applying that formula, you will get minus 1 squared d squared over ds squared, and then multiply with the sine 2t Laplace. So that will give you this, and please solve until you get the final answer. Next, we have time convolution and frequency convolution property. So time convolution property, meaning that you apply the convolution part in the time domain. So you have xt convolute with ht. So what happened in the frequency domain is that is a multiplication in the s domain. So xs time with hs. Same goes for the frequency convolution property. So when convolution happens in the frequency domain, so you have here xs convolute with hs, okay, times with 1 over 2 pi j, because it's in frequency domain. So what happened in the time domain is that you just have to multiply it. So just multiply xt with ht. So you can see the duality properties over here. So the convolution of two signals consists of time reversing one of the signal, shifting it and multiplying it by point with the second signal and integrating the product. Last but not least, you have the initial and final value theorem. So how to find the initial and final value of a function at t if we know its Laplace transform? For initial value theorem, meaning that you want to find the initial value of the time domain, so you have at t limit t is nearing 0. So that will give you a limit of s as s is nearing infinity. So for the final value theorem, meaning that you want to find out the final value in the time domain, so you have st limit from t nearing infinity. So what happened in the frequency domain is that you will have s as s, limit s is nearing 0. See this example over here. Find the initial and final values of the function whose Laplace transform is hs is equal to 20 over s plus 3 times s squared plus 8s plus 25. So let us find out what the initial value first. So h0 is equal to limit s hs, s is nearing infinity. This is when you have applied the Laplace transform. Okay. So you have limit s nearing infinity for 20s over s plus 3 times s squared plus 8s plus 25. So you are multiplying hs with s. So that's why you have 20s here. So after that, we are going to divide everything with s squared because the highest degree over here is s squared. So divide everything with s squared. So you have 20 over s squared over 1 plus 3 over s times 1 plus 8 over s plus 25 over s squared. After that, we are going to plug in s is equal to infinity into the equation. And this will give you 0 over 1 plus 0 times 1 plus 0 plus 0. And finally, you will get 0 for the initial value. Next, we have to find the final value. So the final value is when your h is infinity. So that will give you limit shs, s is nearing 0. So multiply your hs with s, so that's why you have 20s over s plus 3 times s squared plus 8s plus 25. So now you have s is nearing 0. So just plug in s is equal to 0 into all your into the equation, okay? And finally, you will get your answer to be 0 as well. So both your initial and final value for this example is going to be 0.